Hey guys, how's it going? Getting a lot of inquiries about an explanation as to how and what I did to my Shapeoko. Um, as you can see, I've got even more upgrades on this thing since the last video. I've got quite a bit more going on here. So I've got what you can see here is new closed loop steppers all around. And I basically replaced the original open loop stepper motors, and I kind of regret not doing that a while ago, just because the closed loop stepper actually gives feedback to a controller and can actually halt the process if you lose a step and it's unable to recover. So what's happening is there's actually an encoder in the back of these that monitors the position of the rotor in there based on the information being given to it. So if it's told to move a certain distance and that equals a certain amount of steps, and if it does not complete that many steps, the encoder is what tells it if it did or not. And if it didn't, the motor will actually automatically compensate and move to recover that lost step automatically. So basically what it does is it eliminates any potential for losing any steps during a job that you're running. So I can show you what I mean here. Right now I have the machine just sitting here on idle, and if I grab one of the ball screws, it will fight me. The more I try to turn it, it'll automatically go right back where it was. It knows that it's losing steps, and it goes right back. So it takes quite a bit of force to do that. I haven't actually set up the amount of holding torque and how far it can go out of step before it actually throws an alarm code. But right now I'm just using the auto tune, and it's about a full revolution before it actually errors out. That's the default setting. So I'm probably going to shorten that once I get I have an RS-232 to USB cable coming for the drivers that I have for these, so that I can set them up the way I want. But yeah, anyway, I've got closed loop steppers all around now, and everything is kind of wired up and tucked away a little bit cleaner than before. I've got, the wires here are hard to even see on this one, so you have to look down there, and they go down underneath there, and then they're hidden in this little track. There's like a little trough there, and they come out right there. So it's just a much cleaner setup than before. Had to expand the enclosure just a little bit more because of the encoders stick out a little further than the original stepper motors. But anyway, yeah, so I've got ball screws all around as well now. Slowly but surely I've started with a regular Shapeoko here, and I've ended up here. It's quite a bit different. The only thing original that I'm really using here are the extrusions and the brackets, the steel brackets on the bottom, pretty much. Everything else is pretty much different, not original. I bought the HDZ axis that I am using. It's a very nice Z axis. It's way higher quality than the rest of the Shapeoko. If you have just a standard Shapeoko with V wheels and stuff like that, and you get a Z axis like that, it's like putting a Ferrari engine in a Prius, kind of. But it's very well made. Anyway, so yeah, ball screw all around with linear rails all around. It's kind of the ultimate router setup. Really, you can't really get a whole lot better than this. These brackets are kind of an extension of the ones that Dan Story has designed. Got my little touch on there, though. They're a little bit different. I kind of engineered them to be a little more compact for these ball screws, to get as close to the extrusions as possible, to try to keep this thing as compact as can be. There ain't a whole lot of room. There's just a couple millimeters on the side there for that stepper, and there's just a couple more millimeters this way on my Y to fit in my enclosure. I just don't have a lot of space in my shop here, and I'm trying to just make it so it takes up the least amount possible. So yeah, but anyway, I've got ball screws all around now. Special brackets I've made to make them work. These ones are basically a mirror copy of what Dan's Story has designed. And then I've got all around on all 4 Y corners. And then I'm using the original those brackets here, the sub brackets that bolt down to the linear rail trucks. Those are original. The uprights are different. So those I had to recreate to make the ball screws work. From what I had before was belt drive linear rails all around, and I just got tired of the elasticity of the belt and basically the spindle when it's moving in the X or Y, mostly in the X with belt. It would create a resonance thing, like a special sort of a resonance phenomena that would cause it to wobble back and forth. Kind of, it would basically, the motor would step, and it would swing it back and forth. As it would step, it would bounce back, and it was kind of resonating back and forth. If you hit it just right, you got to hit just the right tool feed and speed with it to do that. But it would basically throw the spindle into areas of the stock where it shouldn't be going. The Y wasn't so bad because there's two belts performing the same function, but mostly the X, like I said. So that's what caused me to go ahead and take the ball screw plunge. Anyways, yeah, so that's not it. I've also upgraded the controller to a Masso G3, which is a very, very nice controller. You can see my stepper drivers, my closed loop stepper drivers over here. Everything is all wired up. So I've got the Masso G3. They're expensive, but they're a very nice controller to transition from. It's a very nice all-in-one solution, similar to the Carbide 3D board, but it's extremely more powerful, way more. This thing can do 5 axes. So I've got my 3 X, Y, and Z there. There's A and B left open still. You can actually use axis A or B. You can use 2 axes for your Y to allow for auto squaring. So you'd have 2 limit switches, one on each side of your Y, and it would, because you're using 2 independent axes, it will actually auto square your machine. I don't really need that. I'm just using the same signal from my Y here. I'm running it to both of my Y stepper drivers, and they're functioning as one single axis. But this is a very nice controller. Like I said, it's very adaptable. It has built-in Wi-Fi. It's got the PC built right into it. So yeah, so you can load it through USB thumb drives, and then there's actually 4 USB ports back here for different thumb drives and interface devices like keyboards, different types of controllers, mouse. You can have different peripherals hooked up. This is just a trackpad keyboard combo here, and that's what I have hooked up for controlling it. And then the other one is just a thumb drive for storing data, G-code files on, and you can actually send the files directly to it through Masso My Link, right from your workstation. So there's my workstation down there. I got Fusion open, and you can basically save tool paths and send them through Masso My Link over the air, instead of having to fumble around with thumb drives and stuff like that, which is pretty nice. Very powerful. So I've got the drivers set up right now at 3,200 steps per revolution. So I think what the Carbide 3D board was doing before was half stepping, which was basically, or quarter stepping. So the half stepping would just create 400 steps per revolution, which is basically double the amount of full steps that the steppers would have originally. So that's why the resolution isn't that great with that controller, because I believe it was only doing half stepping, so that would allow for 400 steps per revolution, and your resolution, the maximum resolution that's achievable, was, I believe, 0.01 or 0.05 millimeters or something like that. I think is the smallest increment that it could move with the belts. The thing is, when you add ball screws, your pitch allows for higher resolution, but when you update the steps per millimeter in Carbide 3D, it still only moves at that specific resolution as it did when it was on belts. So I could not get the resolution that I wanted by switching to ball screw. So when I did the ball screw upgrade and I got the controller set up, or got the steppers all set up, the ball screws, and I went to use the thing for the first time, I updated my steps per millimeter. I was hoping that I was going to gain resolution through the ball screws, but it didn't work that way. So anyway, yeah, that's when I began looking at controllers. I would have done all of this all at once, knowing what I know now. I would have done it all at once instead of doing this all incrementally. Um, I think this is probably about as close as you can get to a mill before you actually go with a mill, like a Precision Matthews or Tormach or something like that. It's about as close as you can get before you, like I said, take that step. But anyway, yeah, everything is good and up and running here. And then I've got a power supply under here that is supplying DC power to that bus bar over there, and then that's splitting off into all of the drivers. 36 volts. These can draw, they're allowed to draw up to 600 watts. So that's quite a bit of power. These are rated at 4 amps each. So 16 amps they can pull together at so 4 amps each at 36 volt. So yeah, they're able to pull a lot more power than a regular open loop stepper can. So these were, the originals were probably about 2 amps or something like that. These can pull, like I said, 4 amps if they're allowed to. And then what's really cool, I want to go over these one more time. What's really cool also about these closed loop steppers is they run cool, because if you look at these drivers, you see there's no amp setting. You can't, there's no dip switches for the amps. It's only for the resolution and then your motor direction and all of that stuff down there. It's automatic. That's why. Basically, these motors will only draw the amount of amps that they require. And when they're sitting here idle, they don't require a lot of amps, so they don't draw a lot of amps. They're much, much more efficient, and they're quieter, and they're also, like I said, they will ramp up the amps as they dive into a cut, and fight to, you know, they'll, like I said, they'll fight you. So it really takes a lot of torque to try to get them to lose a step, and that's before I set anything up. So anyway, yeah, so I would definitely, no brainer, get some closed loop steppers. But what that means is you're going away from the Carbide 3D board, which is another thing that I would recommend. Linux CNC, Mach 3, Mach 4, Centroid is another option. I just really like the Masso and what they've done there, because you have the PC built in. And then there's a VGA port right there that goes down. And then I have my monitor right here. So this is the Masso GUI right here. So you can see I have a tool path loaded up right there. You can actually see the tool path. There's a lot of really powerful features in here that you can use to recover your work if there's an issue or something like that. You can do automatic tool changing. There's automatic tool changing features and stuff like that in this. There's lots of different commands that you can use. Anyway, so I actually have, yeah, oh, one more thing. So you can see I'm using the original Shapeoko bit setter. This functions the same way as it did with the Carbide 3D board. I am not using the original touch block though. So that works a little bit different with the Masso. So instead of modifying that one, it was expensive and I didn't want to modify it. I just went ahead and made my own quick. It's just a cube. It's probably not perfect, but it's close enough to touch off on my work. And it's just a simple grounding wire going to a piece of aluminum. There's no electronics or switches or anything in here. So that just makes continuity and it sends an input when it makes continuity from the ground when I touch anything that is grounded to the Masso, and then the Masso knows so it can probe off on things too. So the probing is somewhat similar. So I'll show you here. This is where the probing is. So you can probe off of the top of your stock. You can probe the left side of your stock, the front side, the right side, back side, and then you can probing and do probing holes and things. You can set the offsets right up here. So if you're probing with a 1/4 inch shank or something like that, you just set that right there. It'll automatically compensate for you. Anyway, there's quite a bit to it. I don't need to go over everything, but anyway, yeah, so that's what I was doing. I also have a jogging pendant here, which is nice. So I can actually set the resolution that it moves. So right now I have my X selected. So I've got it really fine right now. So one little tiny click. You can barely see it start to move. So it's barely moving. That's because I'm in the lowest resolution. So if I move up to the next one, you can see it moves a little faster. Then you can flip between your Y. So these steppers are really quiet. The only noise I'm hearing is basically the machine rolling on the screws and stuff like that. And there is some vibrations transferred that I do hear, but they're very quiet compared to the original. So I have this thing set up to go 10,000 millimeters a minute. So I'll show you how fast this thing moves around here. I'll just home the machine. Show you what it does. So I'm just holding the home down right there, and now we'll let it go. So having it wrap it around much quicker is nice because it saves a lot of time on work. So it'll automatically move and start probing down. I don't have a tool in there, so I'm just gonna pretend like it hit. So yeah, that's what I have it set up at right now. And it can do that easily. These closed loop steppers are extremely powerful compared to the original steppers at high speeds, especially. They're way less likely to lose steps and lose their position, or that's basically the same thing. But they're way less likely to basically give up compared to an open loop stepper. I can basically lean all of my body weight into this machine and push as hard as I can against this machine while I'm rapiding 10,000 millimeters a minute back at me. I can go almost horizontal into this machine and it'll stand me straight up all on its own without even blinking an eye. So anyway, there's a lot of nice advantages here. 2.2 kW. There's a couple other things I can go over, but it's getting long, the video. Just wanted to give an update on where I'm at with the machine. I think I'm finally where I want to be with this thing. If I had no machine at all, starting from scratch, knowing what I know now, if if I was going to be cutting metal like aluminum, that's pretty much what I mainly cut with this. I would have gotten a Precision Matthews mill and gone that direction instead. But I didn't know anything about CNC before I bought this machine. It was my first machine, and it got some prototypes done for me that I was able to produce, and my demand and knowledge has gone up just unbelievable. And like I said, I would not recommend taking a Shapeoko from stock to this. It's a lot of work. I don't think you really save a lot of money. I think you can probably buy a machine that's set up like this. For it'll save you a lot more time and money in the long run. I just wouldn't recommend doing this from scratch because it's not for everybody. If you mess up, you can easily end up in a spot where it ain't gonna work out. Like these brackets, if you get your design wrong on that, your bolt hole location or something, and you tore your machine down to make the conversion, you don't have a machine to get new parts made because it's torn down for the upgrade. Unless you got two machines for redundancy there, you can make new parts in the event of an issue coming up. But it's real easy to have binding on the ball screws and the linear rails. There's a lot of issues that can happen. So if you're planning on doing this, it's not that hard. I'm gonna tell you right now, I pretty much know little or nothing about CNC machines, and I was able to pull this off. So I think that anybody with half a brain, that knows how to do CAD and design and things like that, take really good measurements on things, can probably pull it off too. It's like I said, it's not that hard, but it is definitely not for everybody. But be ready to end up about where I'm at because linear rails without ball screws kind of doesn't really cut it for me. It'd probably work good for guys with wood and stuff, but for cutting metal and stuff, you'll probably end up getting ball screws. They have linear rail ball screw combo motion platforms that you can buy on Amazon. They have the linear rail and the ball screw combined. That would have been nice. I would have gone that direction if I'd have gone rails and ball screws at the same time, but I went rails and then ball screws from belts. So I would definitely go that direction if you can. What else? I don't know. I'm trying to just kind of go over everything. Oh, I guess I didn't go over the fog buster at all. I've got this all hooked up. That right there is for the mist, the lubrication mister, and that goes out to a solenoid valve right there, and then it goes all the way out into the garage for my air compressor through the hose and all that. And anyway, yeah, so there's an actual mechanical switch. I'll move my so you can see the little switch right there. That will automatically, when it goes to the home point, it'll hit that switch and turn off the mister. And yeah, so then I've got a little shrink wrap on there to help protect because it'll kind of vibrate around a little bit while it's cutting, and it can bump into your collet nut, and that is just soft brass, and it can probably wear a hole into the end of your fog buster nozzle over time. So I put a little shrink wrap on there to help kind of protect it from that. Anyway, yeah, so that's pretty much it for now. Oh, I can go over the little bit of an enclosure here that I have. So I've got the just plexiglass, and then it goes up there, and it's just magnets that hold it in place. And it's not a full enclosure. I don't have a top. Everything else is enclosed. So what I'm going to be doing is putting a shower curtain, a little short shower curtain that's going to go around and hang just like that, so I can kind of swing it around rather than build a huge giant. I mean, it's already big, but rather than going to the ceiling with my enclosure, I don't run my tubing and my power wires for the spindle through the drag chains, because I want to be able to take it out and use my tapping head that I have here. That's a whole nother thing. So I do interchanging spindle heads, and you can't really take it out. So that goes right there when I'm not using it, and this one goes in there where that is. So that's why I did not route the hose and cable wire through the drag chain. Yeah, it's just a simple piece of plexiglass. It's really, really nice. I would absolutely recommend an enclosure for sure, especially if you're in a clean work area. This is basically a bedroom in my house that I've converted into a shop, and it's a very small shop, and I don't want to be tracking aluminum chips all over my house. So this is basically what I do to contain them. Anyway, so that's about it, guys. Go ahead and send me some messages or whatever. If you have any questions or anything, just let me know. I'll do my best to try to help you out. Any advice I can give, I'll do my best. So, all right, so take care, guys. Thanks for watching.